All right, so this is our last three-dimensional figure that we're going to be identifying the volume of and highlighting other variables within. And that is a sphere. So a sphere is, right, think about a three-dimensional, it's a ball. It is anything really circular. Um, yeah. Now the formula for the volume of a sphere is these two squared or rectangles, which mean the same thing. Either it's 4/3, and this is very similar to something that we've done in the past before. It's pi r, and instead of squared, it's cubed, which means you multiply that number by itself 3 different times. Okay, or you can think about it like this: is simplifying the numerator, which would be the radius squared times pi times 4, whatever that is. We divide it all by 3. Okay. Now, where do we get this formula from? We should have watched a video before this, but really, in a real life figure where we have a cone with the same radius of a cylinder, right? It would take 2 cones filled up with water to completely fill up a cylinder. So, if you get right for one cylinder, I meant to say cone. Pi r squared times h divided by 3 plus another pi r squared h divided by 3. If you add up these two, there's some more arithmetic involved, but you can see where we're getting the divided by 3. We can see where we're getting the pi. We can see we have a r. Here we have a r squared, but something happens with the h for us to get r to the third power. And, and then we also have 4 in the numerator. Okay. All right, but I'll get rid of that for now. But pretty much the only value that you're going to need is the radius, because that's all a radius has. So, or that's all a sphere has. This right here is the same distance as the center to the edge right here, but it's also the center to the, maybe we can think this as a far edge of the sphere, that base circle. All those distances, all those 3 line segments that I drew, those are technically all congruent. Okay, but pretty much this just to say, all you need is a radius, and then you can find the volume of that sphere. Okay, so let's go to the one off to the right. Determine the volume. So what we have here is a sphere with a radius of 3 yards. And if we draw this, let's say I separate this into 3 sections, maybe something like this and this. And I'm going to use this line segment right here for one of these segments. That looks like maybe it's something like this. Okay. Now, if I draw a square with that side length where it's all equal, and then after draw a cube using that side length, right, this is what we would say is 1 cubic yard. Right, it's a cube where each side length is 1 yard. We're really just asking ourselves how many of these cubes could fit into this object. Now, think about it as filled up with water or some type of liquid. How many of those filled up with liquid would it take to fill up a sphere with a 3 yards as its radius? So, as we start, always write out the formula. I'm going to use this formula here. So, V equal to 4 pi r cubed divided by 3. So the steps, some steps are familiar with a cylinder and with a cone, right? Slightly different because now we have a cube here, okay? But let's fill in what we know. We know that the radius is 3 yards. So I'm going to put r equal to 3. All right, let's plug in. I know there's a lot of 3's going on. Instead of r cubed, we're going to have 3 cubed. And it's all divided by 3. Our first step here is to simplify 3 cubed. Right, you can use a calculator, but really what this means, it's 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So let's plug that here. As I rewrite this, let me put 4 times 27 right next to each other. I'll put pi just kind of off to the side, and all divided by 3. At this point, let's simplify our numerators with 4 times 27. 4 times 27. We can use a calculator, but like I said, I'm just going to do this off to the side. We'll use a calculator when we get to more complex parts. 7 times 3 is 21, so put the 1 here for the ones place, and then 2 here for the tens place. 3 times 2 is 6, plus 2 is 8, so this is 81 pi divided by 3. And you can actually figure this out because we technically already did this, but 81 divided by 3, right? 3 can go into 8 twice, that's 6. 8 minus 6 has a remainder of 2, bring down this 1. And, oh, I realized I just made a mistake. Oh, that was the mistake, whoops. Sorry, I made a mistake here with this 81. So I was supposed to multiply with 27 times 4, and I multiplied it with 27 times 3. I apologize for that. But let's figure this out now. 27 times 4 is 28. 2 times 4 is 8, plus 2 is 10, so this is 108. Apologize for that. 108 pi. Now we'll take this and divide it by 3. 108 divided by 3. And you can tell if a number is divisible by 3 if you add up the digits. Right? 1 plus 0 plus 8 is equal to 9. 3 can go into 9, meaning 3 can go into this bigger number. 108. Alright, now let's do this. Let's erase that. 108 divided by 3. 3 can go into 10 3 times. 3 times 3 is 9. 10 minus 9 is the remainder of 1. And bring down this 8. 3 can go into 18 6 times. Evenly with no remainder. So it looks like we have 36 as our answer there. So we're going to put our one of our final answers is V equal to 36. And we'll put pi right next to it. And this is cubic yards. Yep, yards. All right, you might see your answer in terms of pi, or right, we can multiply it by 3.14 as a final step to get our final answer, potentially right into the nearest hundreds place. So let's multiply 36 times 3.14. I'll use my calculator for that. 36 times pi. All right, this is 113 and 4 cents. So 113.04. So final answer. Cubic yards again. The only thing is that we multiply with pi. Okay, there we go. So it turns out that maybe this isn't quite to scale, but it'd take about 113 and 4/100ths of these cubes to fit into this sphere with the same radius in terms of yards. Okay, well, in terms of yards. All right, let's move on to the next one. So right here, again, we're finding the volume. So we need, as always, the radius. Now the radius, we don't have the radius. What we have here is 12 centimeters, and that is, since it's directly in the middle of this line segment, we need to figure out, right, what is the radius here. And by now, we've worked with this quite a bit. We should know that the radius is 6 centimeters. From the center to the edge of the circle, base circle, we'll just put r equal to 6. We're going to get some big numbers, but as we start this, we always write out the formula. 4 pi r cubed divided by 3. And we're going to plug in 6 for the radius. And we're going to go through the same steps as the other problems. Or the other problem. So we're going to work on 6 cubed, which means 6 times 6 times 6. 6 times 6 times 6 is a very big number. Right, 6 times 6 is 36. And then 36 times 6, we'll do that real quick. It's 216. 18 plus 3, yep, 21. 216. So we're going to rewrite this as 4 times 216. Pi at the very end. Pi is just always at the end. And then now we multiply our coefficients in our numerator. 4 times 216. This has got to be 864, I believe. So 4 times 216. $864. Right on the money. So 864. 864 pi all over 3. Can 3 go into this number if we add up? Right, 8 plus 6 is 14, plus 4 is 18. Yeah, 3 can go into 18, so 3 can go into this bigger number. Let's use our calculator again. So 864 divided by 3. 864 divided by 3. Just have to remind myself. 288. All right, running out of room over here, so I'm going to bring this now over here. Whoops. V equal to 288 pi, and this is one of our answers. This is in terms of pi. In terms of pi. So this is centimeters, as I'm seeing right here. Cubic centimeters. And if you want to know how big a centimeter is, it's pretty much how big it should be a dime, I believe, a dime or a penny. Like how wide a dime or a penny is, that's 1 centimeter. All right, now let's multiply with 3.14. So 288 times 3.14. Ooh, big number. This is 904. I think this is $904.32. So 904.32. Round to the nearest hundredths place. Whoops. 904.32 cubic centimeters. And there we go. So whatever it is, let's say a cubic centimeter is this big. It would take 904 of these and 32 hundredths of one to fit into this sphere with the same dimensions, with the same unit. All right, and now let's work on the last one. Determine the radius. So now we're given the volume. We do not know what the radius is. So slightly different, and looking at the assessments that the quiz that we took on volume of a cylinder and cone, it really seemed that we needed some practice on, if we're given the volume, what do we do to figure out some other type of dimension, being either the radius or the height if we're looking at a cone or a cylinder. But like we said, as always, we're going to try to be organized, rewrite our formula, and then we're going to plug in what we know as we go on. I'm going to draw a line here. Okay. Now we know that our volume is 972 pi, and this is cubic meters. So instead of V, I'm going to replace it with what we just highlighted in that bracket. I'm going to put 972 pi. Off to the right, nothing happened with it. I don't plug in anything for the radius, so we're still going to keep that. Okay. Now, if you're not sure what to do for your first step, it might be beneficial to write GEMDAS, or when you're solving the equation, you actually go reverse order of GEMDAS, which is SADMEG. Now, if we're looking in relation to the radius r, what are the other things doing? This 3 is subtracting. Subtracting. It is dividing. But in the numerator, this is all a part of a group. So there's technically parentheses around there. So there's technically, multiplying by 4 in the group, multiplying by pi in the group, and then an exponent in the group. So there's really 3 things in that group. This is just to say I have to get rid of this 3 that is dividing here. So to undo that, let's multiply both sides by 3. All right, goes away, goes away. 3 times 972. It's going to be a big number. 2,916, so 2916. 2916. Don't forget the pi. And then when off to the right, we're still left with just our numerator. No dividing by 3 here. But if we can also clarify what is happening here, I'm going to rewrite SADMEG one more time. Now everything was a part of the group, but now that I've gotten rid of the denominator, now right we're just left with that group. But what operations are happening in that group? 4 is multiplying, pi is multiplying, and then we have an exponent of 3, right? This to the third power. So this tells us let's get rid of, first, if we're going from left to right, get rid of multiplication in one of two ways. Right? There's two things that are being multiplied. So to undo multiplication, we're going to divide. I'm going to divide by 4 to both sides. And you're welcome to stop at that point. Just divide both sides by 4, see what you get. But for me, I prefer to be a little bit more efficient and combine kind of two steps into one. Right? We're going to divide both sides by 4 pi. And we've done this when we worked with solving for the radius or the height with either a cylinder or a cone. Right? What happens here? Pi divided by pi is 1. That line represents 1. 4 divided by 4 is 1. And to express why is it 1, right? If you have 4 cookies and 4 friends, right, and you're asking the question, how many cookies does each friend get? Each friend gets 1 cookie. That's why it's 1. Or when you divide, you're thinking of how many groups can you form. And then pi cancels on the left side. Let's figure out what is 2,916 divided by 4. So 2916 divided by 4. 2916, whoops, wrong symbol. Divide by 4. 729. So 729 equal to. The only thing that didn't get crossed off on the right side is 3 cubed. Now we're trying to ask ourselves the question, right? What 3 numbers, if multiplied together, equals 729? Now that's kind of hard to figure out. So what we have to do is something called, right, not the square root, but the cube root. And cube root looks like this. There's a 3 on like the knee of this radical. This is what we call is an index of 3, right? Technically when you have a square root, you actually have a tiny 2 there, but we don't typically see it. So you need to try to find this symbol in your calculator. Many calculators do not have the cube root. I think if you just Google calculator, I don't think that'll work out. Or maybe even your app on your Chromebooks. But let's see here. Cube root of, well, actually, let's write that in. We're going to take the cube root of both sides. So we have the cube root of 729 equal to the cube root of r cubed. The cubes, just like how squares undo square roots, cube roots will undo cubes. We're left with r. But let's figure out the left side, cube root of 729. So how you do this here? I can't quite zoom in here, but if you look at the top left of my keyboard, this option right here, I'm just gonna keep clicking it. It has an x as the index to a looks like a radical, and then y power. In order for you to find the cube root, you have to type, at least for my calculator, you have to put 3 first, and then that button. So this says the third root of, let me give you an example. The third root of 8, enter. It equals 2. The reason is because 2 times 2 times 2 equals 8, right? 2 times 2 is 4, 4 times 2 is 8. But let's figure out for our problem. So again, the 3, that root, we'll put 729, enter. It is 9, because 9 times 9 times 9 is 729. Let's prove that here, but let's put our answer, and our answer is in terms of meters. But just off to the left, right? 9 times 9 is 81. 81 times 9, where 9 times 1 is 9, and then 8 times 9 is 72. So it is 729, as we see right here. But our answer is 9 meters. It is how long this radius is. Let me write that in here, 9m. All right, that's it. That'll be it for this video. We're going to get to our assignment afterwards.